In this video, we're going to talk about interest parity. First, we're going to start with the concept of covered interest parity. Now, these conditions are important because we're going to use the equation that we develop for this concept of ultimately for uncovered interest parity. We're going to use that in the subsequent chapters to talk about models for exchange rates and specifically to look at how monetary policy can affect exchange rates. And so the basic concept is really, it's this asset, what we call an asset approach or an asset-based approach. The idea here is imagine if you have $1 to invest, okay? And you can invest that in a US bank here, and what you'll get at the end of 1 year is you'll get your dollar plus the interest rate that is currently being paid on US denominated deposits, okay? And here we're just making it really simple. We're saying there is one interest rate in the US, okay? So this would be what you would have at the end of a year, right? So your return would be the rate of interest, okay? 5%, 3%, whatever that might be. Now the alternative would be you could take that dollar and you could invest it in a bank, let's say somewhere in Europe in one of the Euro countries, okay? One of the countries that uses the euro, say in France. So what would that look like? Okay? Well, now if you take that $1, how many euros will you get for that dollar? Well, if you take, remember we have our different exchange rates, right? So remember, how do we think about it, right? The dollar to euro exchange rate tells us how many dollars you need to buy a euro. Okay? So in other words, this is saying, well, you know, if I have $1, I can buy, let's say, 0.8 euros. Okay? Of course, the flip of that, what we want to look at is the euro-dollar exchange rate, which is just the 1 over the dollar to euro exchange rate, right? Because the euro to dollar exchange rate tells us this is how many euros I need to buy $1, right? So I'm taking this $1, so that's also telling you how many euros I would get. So I could take my $1 and I will get 1 over E, right, the exchange rate, that's the dollar to euro exchange rate. And so that's immediately. I take my dollar, I convert it directly into euros, and that's how many euros I have. Now, at the end of 1 year, I will take this number of euros and multiply that by 1 plus the interest rate that's being paid in the Eurozone, okay? So that is how many euros I will have at the end of 1 year. Of course, now I need to convert that back into dollars. And how do I do that? Well, I would do that by going back to, right, our dollar to euro exchange rate. The thing is, I'm looking at it from the perspective of today. Right? I don't know with any degree of certainty. I might make a good guess, but I don't have certainty as to what that exchange rate is going to be in the future. What I could do is I could use the forward exchange rate. Right? And that, of course, tells me, right, this forward rate is a rate that lets me convert dollars into euros at a specified amount at some point in the future, right? And so in this case, for the sake of our example, that future date would be 1 year from now, because we're looking at depositing this dollar in the bank for 1 year, taking it out a year from now, and then I'm going to, right, if I'm doing it in the US, that's what I have, or I convert my dollar into euros, invest it in a, say, French bank and earn the euro interest rate or the euro area interest rate on that. Right, so again, this product here tells me how many euros I have in a year. And then a year from now, I'm going to convert those euros back to dollars using the future exchange rate that was in place when I first sent that dollar over to the French bank a year ago. So in other words, then we multiply that by that forward rate. Right. So this is, on the left-hand side, that's the return if I just invest my dollar in the US bank. On the right-hand side, that's my return if I invest that dollar in the French bank, and it's the total return, that is, once I've converted it back into dollars. What covered interest parity says is that those two returns need to be equal. If they're not equal, then that means people would rather have their money in one place. So like, let's say that the return on dollar deposits is higher than it is on euro-based deposits, right? So if the left-hand side were greater, right, then what would happen? In that case, everybody would start sending their money, say from Europe, or a lot of people would at least send their money over to the US. And that would actually cause the exchange rate to adjust to bring this into line, right? It's an asset-based approach. So we really think about this, it's the supply and demand for the two currencies ultimately. Right? So that can't hold true. And so this is our covered interest parity condition. To clean it up a little bit, right, that right-hand side, it's just easier to look at it if we write it as, right, the forward rate over the spot rate times 1 plus the interest rate in the Eurozone. So that's covered interest parity. And why do we call it covered? Well, it's because we've eliminated exchange rate risk by using the forward rate. Okay? Now, a very similar concept is what we call uncovered interest parity. With uncovered interest parity, we replace the future exchange rate with the expected exchange rate. So now that condition is right, so the superscript E here reflects the fact that we're talking about the expected exchange rate. Right? And of course, we keep the spot rate. Right? So again, you can see, right, very, very similar equations. The only difference is that we've replaced the forward rate here with the expected exchange rate. And so in this case, there is some exchange rate risk, right? This is the expected exchange rate, but of course the actual exchange rate could turn out to be something different. So you are suspect to some exchange rate risk. This equation right here is actually going to form the basis for the monetary approach to exchange rates that we're going to look at in a subsequent chapter.